The matrix diffusion problem uses a swept mesh, and let me show you how to set this up. The problem involves slow down this thin fracture here, and so we need to mesh this in an efficient way, and a good way to do that is using what's called the swept mesh. The way this works is that I first put a mesh on a surface, and let me go and see if I can show you that surface. I'm going to hide this upper block here. And so when I set this mesh up, I use this free triangular meshing of the surface, and I select this upper surface of the fracture and mesh it. And then the next step is to use a swept mesh, and I select this thin block that is the fracture, and I go ahead and mesh that. And what I get then is a mesh that looks like this. So here's the, let's see, here's the triangular mesh that we did on the top surface. Let me see if I can get there we go, see a little bit better. So here's the triangular mesh on the top surface, and then when I did the sweeping process, I swept it down straight through and it turned the element into this triangular prism. Okay, so that's what the sweeping process is going to do. In this case, we only swept one element, but we got this broad, thin element. If we didn't do that, if we just meshed this volume with a tetrahedral mesh, I would have got many small tetrahedrons in here. So there would be many more elements in this thin layer. And it would make the problem very cumbersome to solve. But so this is a much better geometry for that kind of a long, broad, thin layer. Okay, so we need to go and continue on with this process. Let me go and reset the hiding. And so I've got this subdomain meshed, and I'm going to go and repeat that. So we're right here in the meshing process, and what I did was to put in another sweeping command and do that right there, and I selected this subdomain, and so I go ahead and run that, and here's what you get. And let me zoom out a little bit. So there's the mesh, and you can see that it's on this face it's rectangular, but if we look up here at the top, we have the triangular pattern that we had on the fracture face. So you can see these are all triangular prisms, and I have a closer spacing, smaller elements here right next to the fracture, and then it gets bigger. That's because the gradients will be greatest right next to the fracture. And I did that by, I had this the size grading by using distribution here, and I have 20 elements. That's the number of elements that I have in this direction, and the element ratio is the ratio, this determines the size of one element relative to the other. So if I make it, for example, 1, then the elements are all the same size, and you can see that makes it all the same size here. If I make it even bigger ratio, then it makes it even finer right here, even smaller. Okay, I may want to reverse it, so I can, or no, may want to reverse it right here, and that puts the big elements on this side and the smaller elements on the other side. Okay, so it gives me some flexibility. Let me put it back, and so I've got to repeat this now on the bottom side. So I select this subdomain, and let me go and get rid of these guys so I can see what I'm doing here. Okay, so now I can go and just run this, and it works okay. Oops, don't want to do that. We get rid of these guys again and turn this hiding off. Okay, so there's the mesh. What I did was to take this command here and copy it or duplicate it and generated it again. And actually, when I did that, it didn't work quite right. I got some funny result. And the reason for that is because what happens is that when you put in one of these swept commands, it tries to figure out what you want to do, and maybe it guesses right, but maybe not. And in this case, when I was setting this up, it didn't give me the right results. So what I had to go in and do is and so I selected the subdomain here, but then I had to specify the source faces and the destination faces. And what's going on here is the sweeping process starts with one face. So you have to have one surface that's meshed, and then it goes and extrudes that through the subdomain. So the source face is where you're going to find the mesh that you're going to want to use. And then the destination face is the face that you're going to go and extrude it to. So the destination face is down here. That's this one. And so when I did that, then it worked fine. But what I think happened is when I first set it up, it thought maybe I wanted that face as the source face. And if I were to try that, it gives me an error. So I need to go back here, and actually that one, that's correct. I want 6 and put the destination face as this one down here. Now it should work. Okay, so that's how you set up a swept mesh. One of the things that you'll find is that you need to be able to go from this surface to the surface down here without there being any anomalous or any interruptions along the path. It doesn't have to be straight. It can certainly be curved, and that's really one of the a nice application for this kind of mesh is on curved like a pipe or a tube, but it does have to be continuous. If I were to put a point here or put a little subdomain region in here, then I couldn't use a swept mesh. So it's not for all cases, but it's quite useful when you can implement it.